A telescope that must stay stiller than the width of a single hydrogen atom is about to hunt for aliens, and NASA just handed 7 companies billions of dollars in contracts to make it real. This is not science fiction. This is the Habitable Worlds Observatory, and what you're about to hear will change the way you look at the night sky forever. Somewhere around 1.5 million kilometers from Earth, at a point in space where gravity balances perfectly between the Earth and the Sun, NASA plans to park a machine so precise, so sensitive, that it could detect a candle flame on the surface of a planet trillions of miles away. That location is called Lagrange Point 2, or L2. It's the same neighborhood where the James Webb Space Telescope currently orbits. But what NASA is planning next makes Webb look like a rough draft. Here's the scale of what we're talking about. The Habitable Worlds Observatory, or HWO, is projected to cost around $11 billion. It will carry a mirror at least 6 meters wide, similar in size to Webb, but built for a completely different mission. Webb was designed to look back in time, to see the earliest galaxies in the universe. HWO is designed to look for something arguably even more extraordinary: life, right now, on planets orbiting other stars. Let that sink in for a second. We are not talking about searching for microbes in ancient rock samples. We are talking about a machine capable of directly imaging planets light years away and analyzing their atmospheres for the literal chemical signatures of biology. But here's the mystery at the heart of this mission. How do you even see a planet that's a billion times fainter than the star it orbits? Imagine trying to spot a firefly sitting 1 inch away from a lighthouse beam, from 100 miles away. That's the challenge NASA engineers are up against. And the solution they've engineered is almost unbelievable. HWO will use an instrument called a coronagraph, a device that blocks out starlight with such extreme precision that it can suppress it by a factor of 10 billion. To put that in perspective, that's roughly 10 times better than anything humanity has built before. Without this technology, the glare from a distant star would completely erase any hope of seeing a small, rocky planet nearby. With it, for the first time in human history, we might actually see another Earth. And that leads to the terrifying engineering problem nobody's talking about enough: stability. In order for that coronagraph to work, the entire spacecraft has to remain almost perfectly motionless while observing. We're talking about a telescope that needs to be roughly 100 times more stable than the James Webb Space Telescope. The instrument portion of the spacecraft cannot wobble more than the width of a single hydrogen atom. One of the smallest, most infinitesimal units of measurement in physical science, and an entire multi-billion-dollar space telescope has to hold steadier than that, while floating in the vacuum of space, 1.5 million kilometers from any repair shop. Why does this matter so much? Because the mission's primary target is almost impossibly ambitious. NASA wants HWO to directly image and study at least 25 potentially habitable exoplanets, not detect them indirectly through gravitational wobbles or light dips, actually see them, actually capture their light, actually break that light apart into a spectrum and read what's inside their atmospheres. Here's where it gets genuinely spine-tingling. Scientists are searching for what are called biosignatures, chemical fingerprints that, as far as we know, can only exist in meaningful quantities if there's life producing them: oxygen, methane. If you find both of these gases together, in abundance, in a planet's atmosphere, that's a red flag for life, because oxygen and methane react with each other and destroy one another over time. If both are still present at high levels, something has to be actively replenishing them. On Earth, that something is us: plants, microbes, life itself. Alongside these gases, scientists will also look for the vegetation red edge, a spectral signature caused by plant life reflecting light in a distinctive way, and other markers like water vapor and carbon dioxide, which tell us whether a planet can even hold liquid water in the first place. So somewhere out there, potentially within the data captured by this telescope, might be the very proof that ends humanity's oldest question: are we alone? Now here's the twist most people don't know. This isn't a brand new idea NASA cooked up overnight. HWO is actually the merger of 2 earlier telescope concepts that never got built on their own, one called LUVOIR and another called HabEx. In November 2021, the National Academies of Sciences released what's called the Decadal Survey, essentially the astronomy community's ranked wish list for the next 10 years of space missions. Their number one recommendation, the very top priority, was for NASA to build a large 6-meter class space telescope specifically capable of hunting for signs of life. NASA listened. In January 2023, they officially announced the Habitable Worlds Observatory as that response, their next flagship astrophysics mission. But building humanity's most powerful life detector doesn't happen for free, and it doesn't happen without political drama. Earlier this year, NASA's proposed 2026 budget nearly gutted the whole astrophysics program, requesting a mere $3.3 million for HWO's technology development, a number so small it barely covers a rounding error for a mission of this scale. That proposal also would have slashed NASA's overall astrophysics funding by 2/3. For a moment, the future of humanity's most ambitious search for alien life hung by a thread in a budget spreadsheet in Washington. Then came the reversal. Congress stepped in. A newly released spending bill allocated $150 million specifically for HWO, a massive jump from that original ask. NASA's administrator, Jared Isaacman, publicly stated that the Habitable Worlds Observatory represents exactly the kind of bold, forward-leaning science that only NASA can undertake, and that the agency intends to move with urgency to accelerate the mission's timeline. So who's actually building this thing? In January of this year, NASA awarded 3-year fixed-price contracts to 7 major aerospace and technology companies to develop and mature the specific technologies HWO will need. Those companies are Astroscale US, BAE Systems, Busek, L3Harris Technologies, Lockheed Martin, Northrop Grumman, and Z-Coat. Some of these names might sound familiar. They've built parts of nearly every major spacecraft flying today. Now they're racing to solve engineering problems that have literally never been solved before, at a level of precision never previously required. One of the most fascinating and slightly unnerving details in the HWO plans is this. Mission engineers want the spacecraft to be serviceable by robotic vehicles while stationed at L2. Right now, if a satellite breaks down in deep space, that's usually the end of its story. There's no repair truck a million miles from Earth. But NASA is designing HWO with future robotic servicing in mind, meaning unmanned spacecraft could potentially repair, refuel, or upgrade the telescope long after launch. This would be a capability far beyond anything currently possible in the geostationary orbit zone we service today, roughly 35,000 kilometers above Earth. We're talking about extending that same idea nearly 45 times farther into space. And here's a detail that sounds almost like science fiction but is very real. The telescope's structure needs to fold up to fit inside a rocket fairing, then unfold once it reaches space, similar to how Webb had to unfold its massive mirror and sunshield after launch. Engineers are designing HWO's telescope, protective baffle, and solar panels so they could potentially fit inside the payload fairings of multiple next-generation rockets, including SpaceX's Starship, Blue Origin's New Glenn, and NASA's own Space Launch System. This flexibility matters because nobody knows for certain this many years out which rocket will ultimately carry HWO to orbit. Let's talk timeline, because this is where patience becomes part of the story. HWO isn't launching next year, or even in the next decade. Current projections place the launch sometime in the late 2030s to early 2040s. That means a mission first proposed in the early 2020s might not actually leave Earth until roughly 20 years later. Why so long? Because nothing like this has ever been built before. Every single piece of technology, the coronagraph, the stability systems, the mirror segments, has to be invented, tested, and proven, sometimes multiple times, before engineers can trust it with a mission this important. Before HWO even leaves the ground, NASA has another major mission launching first, the Nancy Grace Roman Space Telescope, slated for launch by May 2027. Roman won't search for alien life directly, but it will hunt for dark energy and exoplanets using a wide survey approach, essentially scouting the cosmic landscape and helping refine the science that HWO will later build upon. Right now, in laboratories across the country, teams are already testing early hardware, Spring of this year marked the beginning of what scientists call first light demonstrations, essentially the first real tests of prototype instruments designed to prove the coronagraph and stability technologies can actually work at the level HWO requires. 3 industry teams have been bringing physical test articles into specialized facilities to see if their designs can survive the brutal precision requirements this mission demands. This is happening right now, in real time, while most of the world has no idea any of it is underway. Consider the sheer audacity of this project for a moment. Humanity is spending over a decade, tens of billions of dollars, and the combined effort of some of the most brilliant engineers, physicists, and astronomers alive today, all in pursuit of a single question that has haunted human civilization since we first looked up at the stars. Are we alone in this universe? If HWO succeeds, if it manages to image just one of those 25 target planets and finds oxygen and methane dancing together in its atmosphere, that moment would rank among the most significant discoveries in the history of our species. It would not be a probability, not a statistical inference, not an indirect hint. It would be direct evidence, light captured from another world, broken apart and read like a message, potentially telling us that life exists somewhere other than Earth. And if it finds nothing, even that would be profound, because scanning 25 nearby, potentially habitable worlds and finding them all silent, all lifeless, would tell us something equally important about how rare or common life truly is in our corner of the galaxy. Either way, in about 15 to 20 years from now, when this telescope finally reaches its destination at L2 and begins its watch across the cosmos, humanity may finally get an answer to the question that has quietly followed us through every civilization, every religion, every scientific revolution in our history. So here's what I want to know from you. If the Habitable Worlds Observatory does find signs of life on another planet, do you think humanity is actually ready for that answer? Drop your thoughts in the comments. And if this kind of deep space content fascinates you, make sure you follow this page, because we're covering the most important space missions happening right now, long before mainstream media even picks up the story.